Hello, my name is Koen de Rover and you're watching a demonstration of Ekeko. Ekeko is a Clojure library for metaprogramming against Eclipse. What I'm actually going to demonstrate is how to use Ekeko to repeat a large amount of changes within a program. The actual changes that I want to perform are shown here. I had to perform these throughout a huge class hierarchy, and I didn't want to do them by hand. So that's why I wanted to use Ekeko for this. The code before looked like this. You had a couple of annotations on particular fields, and within these annotations you had a type name. After the change, I wanted to have the type of the field on which the annotation resided. I wanted to make this a parameterized type. Which type parameter did I want to use? Of course, the one that was in this annotation. So basically, I want to rewrite or change every field that has such an annotation, such that its type becomes parameterized with the type that you can find within the annotation. And I want to repeat this change throughout all of the classes in the class hierarchy. That's what I'm going to demonstrate now. What you see here is the Clojure read-eval print loop, on which you can evaluate a couple of expressions like this. Note that Clojure is a Lisp, so you'll see lots of parentheses throughout this presentation or demonstration. And what Ekeko enables you to do is just launch logic queries over the source code of your program. So basically, Ekeko enables you to consider your program as a database of information, so logic database. So I'm going to just launch the first query. We're interested in, of course, annotations. This query is going to be evaluated against this program, the one in which all of the changes have to be performed. So let's see what it does. And indeed, we find a lot of annotations for this, a lot of solutions for this query, and each solution appears to be some kind of an annotation. What this does, this query consists of a single logic condition, and this logic condition requires the logic variable node to be an abstract syntax tree node of type annotation. But of course, there are still some subtypes of annotations, such as normal annotation or single member annotation. So using Ekeko, we can launch queries on the read-eval print loop. We can also embed these queries in a functional expression. So for instance, let's just count how many of these annotations are there. And we see that Ekeko found 183 annotations in the source code. Now, what are those solutions exactly? Well, the solutions to a query are tuples of bindings for these variables over here. So in this case, we only have one variable, so we have one tuples of bindings for an AST node each time. And each of these solutions satisfy the constraints of the query. So in this case, the constraint is only that node should be bound to an annotation AST node. We can, of course, apply some functions, some Clojure functions on the solutions of a logic query. In this case, we're going to map over each of these one tuples the function that we obtain by composing class and first. So we're going to take the class of the first element of each of these tuples. Let's see what it is. And we actually see that each binding for node is an instance of normal annotation or of single member annotation. So we actually have live AST nodes in the solutions of our queries. We don't have an AST node converted to a logic fact or to a Clojure data structure. No, we just keep our AST nodes as they are, as Eclipse operates them. And this, of course, facilitates manipulating the solutions of a query. For instance, we can just open them in an inspector, or we can quickly whip up a graphical inspector. In this case, I'm going to open a graphical inspector on a related query. This one consists of two conditions. The first condition retrieves annotation AST nodes. The second condition is going to bind a variable parent to the parent of the annotation AST node. Basically, this is going to give us the method or the field or the type that is being annotated. So let's open this inspector. The inspector looks like this. We have a node, and for each node we have a parent. Let's have a look at some of these annotations. For instance, we have an override annotation, and this override annotation seems to be annotating a method, as you would expect. What we can do then is actually find this node in the editor. So what you see here is just the Java editor being opened on our method can be assigned. We can do the same for our entity properties. So you see that an entity property is annotating a field over here. You can just find this field in the editor, which is quite handy if you want to interactively or incrementally define your queries, that you can always inspect its results like this. Okay, back to the demo. What we saw is that there are quite some annotations of which the parent is not a field declaration, but a method declaration or a type declaration. So let's just filter those annotations out of our solutions, because those are the annotations that we do not want to change. So it's quite easy. We're just going to add a third logic condition to our query. In this case, our third condition requires our parent to be an actual field declaration. So we don't see a lot of difference in the solutions, except that we have some less solutions. We have 173 solutions. We found them in 35 milliseconds. And all of them are just annotations on field declarations this time. But I'm still not very happy. We are supposed to only change annotations, well, only this particular, this particular annotation, this add entity property annotation. So let's just find it by its fully qualified type. So we have here a logic predicate or logic condition type, and then we have a dash name qualified string, which is going to bind annotype to the type that corresponds to this fully qualified name. And then we're going to check whether annotation is actually an annotation that refers to this fully qualified type. Note that in our source code, we're not using these fully qualified types, we're just using a simple type for the annotation. Nobody's going to type the full name of an annotation here. But we want to be sure that we don't find any other annotations. So let's just evaluate this query. And indeed, we find all annotations of this type now. And there are only 104 this time. Okay, so this was actually a demonstration of the first predicate that sits above the abstract syntax tree level. In this case, we're going to talk about types. We can talk about methods that invoke each other. We can talk about methods that override each other. And Ekeko provides a lot of those higher level predicates already for you. If you want to check them out, you can go to the website of Ekeko. In the README, we have a short explanation of how to get started, how to launch your first query, just as I did now. We have some interesting example queries that start with the basic abstract syntax tree relations and then go to some more advanced queries. And of course, we have the complete API documentation. So for instance, you will find more high-level predicates, such as the method declaration that is invoked by a method invocation, the super type of a type declaration, and so on over there. We have extensive documentation of all of these predicates, of course. You can also access this documentation on the read-eval print loop, which is quite nice. So you can just say, I'm interested in all ASTs, Let's say that I wanted to find expressions that are of a particular declared type. Let's say that we're interested, I think, yes, so this is the relation that we're interested in. We're interested in expressions and their type. Expression and their type. Can inspect this query, and then we see, for instance, that there is the value of an expression name.class is class, of course, a Java-line class. The value of this is this keyword or this expression is the class in which it resides. The value of name, well, it depends, of course. But we can. What's interesting is that we saw types from source code, types declared in source code, and we also saw some types that are declared from in the bytecode. So let's just restrict our solutions to expressions of a type that is declared in the source code. No, let's do the bytecode. So let's say binary types. And indeed, all of these types, most of them come from the SDK. So I have Boolean, dates, the list interface, and so on and so on. So you can quite easily explore the Ekeko library just from the read-eval print loop, because we have some very good, or at least good enough, documentation for all of the predicates. Now, what can you do with these logic queries? Well, I already told you that you can embed them in functions, and we provide a bunch of these functions, of handy functions for you. For instance, we have a function for visualizing some particular relations in your source code. What I want to visualize is basically classes, such as this break statement here, that are referring to another class within one of their annotations. So the nodes of my visualization will be classes, and then I will draw an edge between two classes if one refers to the other in one of its annotations. So in this case, there would be an edge between break statement and simple name, because break statement is referring to simple name in this annotation. I'm not going to do this for the whole class hierarchy, but I'm just going to do this for expression subclasses. So we provide an Ekeko visualize function to this end. It takes two queries. The first query will retrieve the nodes that need to be drawn. The second query will be used to draw edges. So in this case, we're going to have type declarations as our nodes, and we're going to draw an edge if one type is referring to another type in its annotations. What you see then are some callback functions that you can use to basically give nodes, give labels and images to the nodes and the edges in our graph. So let's evaluate this. What we see is indeed we have some classes that refer to each other in in our source code. Of course, the styling still leaves something to be desired, but you can always configure this through these callback functions. Okay, something else that you can do is just prototype some development tools or Eclipse plugins even on the read-eval print loop. So let's just find some, let's extend Eclipse with marker or error markers on fields that aren't correctly annotated yet. So we basically want to have a little error marker appear next to this field because the annotation does not correspond to its to the type, or there is basically no type parameter yet for this field. So how can we do this? Well, basically we're going to oops, that's because Clojure is lazy, so we need to evaluate this actually. So we're going to add a problem marker to the solutions to this particular query, which is going to retrieve all of the fields that aren't correctly annotated yet. What we see is that a lot of these classes have gotten additional problems. One of these problems is indeed the type parameter corresponding to the check annotation is missing. And this is indeed the problem marker that we added now. I will leave this open here, this file, because we'll use it later on. So let's make some room. Yeah, okay. So let's just delete all of these markers. In the meantime, okay, so they go away. Very nice. They also went away over here. Onto our actual problem. So we basically want to change all of these fields, the type of these fields, such that it becomes a parameterized type with the type parameter stemming from the argument of this particular annotation. So how can we do this using Ekeko? Well, we also provide some functions for rewriting source code. And the beginning of our program transformation, if you wish, is very familiar. We're just going to launch a query that finds us all incorrectly annotated field declarations. And then for each of the solutions to this query, which consists of a field, type of the field, and the type of its annotation, we're going to, for instance, we're going to create a parameterized type and use the type of the annotation as a type argument for the parameterized type. All of these are just Ekeko functions, such as copy ASD node, create parameterized type, change the property of an ASD node, and so on, are functions that we provide for rewriting source code. The documentation is also available online. So let's evaluate this. Oops, actually nothing happened now. We just got back a bunch of nils. The idea is, well, this can be explained because we haven't really applied the changes yet. We have only scheduled them with the Eclipse rewriting system. Evaluating apply and reset rewrites is actually going to perform the changes for us. When I do this, I would like you to pay attention to three views. First of all, our package explorer on the program that we're going to change. Note that our package explorer, note that a lot of these things are going to change here. At the same time, I would like you to pay attention to this one class from our package explorer break statement, because we're going to see it change at the same time. And then finally, we have here the Ekeko console. And what you're going to see here is that Ekeko is going to process a lot of changes to compilation units. And this is because Ekeko is always notified of changes in the workspace. This way, all of the Ekeko predicates always operate on the current state of the workspace. They're not on an out-of-date representation of the workspace. So let's just do this. Applying. We're seeing a lot of changes over here, all of these bigger than signs. Our break statement got changed, right? And Ekeko was notified of many changes. Okay, I think that's about it, what I wanted to show. If you would like to find out more, I welcome you to check out the Ekeko website, which you can find here on GitHub. So it's just GitHub cederover down Ekeko. Okay, thanks for listening. Bye.